Alright, this video is going to go over how to set up a simple scene in Quelea. So first step would be to look at this main tab, which is the Quelea tab. It's kind of the core components, and they're organized in the order that you kind of need to connect them. The first component that every scene needs is this construct particle component. I'm going to set up my components, and then I'm going to explain what each one of these parameters does. The next thing is we need a system, and the system takes in our Quelea settings. It also takes in emitters. We can take in multiple emitters. We're going to start with just one. So here I've dragged out a point emitter, and I'm going to connect it. So now we have a valid scene. All the system needs is really just some Quelea and an emitter. An environment is optional. The default is kind of the whole extent of 3D space. Alright, so now we have a system, and we need to plug that system into our engine, which is going to run the simulation. So again, you can have multiple systems. We're going to start with just one. So it takes in our system, and it also takes in this Boolean reset. So when you choose reset, it resets the simulation, and when you set it to false, it runs the simulation. So you can see if I plug this in, we now don't have really much of anything because we need to update this scene over time. So that's why we need a timer object. This tells the scene to update we're going to start with 1 second. Alright, so now we still don't have anything, but we clearly have particles being emitted. So the last thing that we need is a way to kind of expose the fields of a particle, and that's where we're going to use the Deconstruct particle component. And this exposes all the fields of a particle component of a particle Quelea. And so now the system outputs our Quelea, and we're going to plug it into the particle Quelea. Here we can see our scene is updated every 1 second, and we're able to see them. Of course, it's a little slow for most uses. It can be useful if you're trying to analyze your scene, but I usually set it to 20 milliseconds, and this gives you a nice animation. So with the point emitter, they're just emitted with kind of a random initial velocity that's bounded by these two numbers. So if I wanted to say only have them kind of travel upwards initially, I could drag out an XYZ vector, and if it's a 0, 0 vector, I plug it into both. That means it has a 0 initial velocity and they're not going to move. However, if I plug in something here, we'll see that now they're all given this initial direction upwards. So if we want them to kind of spout out like a fountain, we might have this initial direction upwards, but modulate the x and the y. So I'll just use this number as well. So here, if I plug in the x and y component here, and the x and y component here, so right now these are still the same vectors, that's why we're getting this result. But here I'm going to make this one negative, as well as the y to be negative. And now they're kind of spout out upwards, but also to the left and the right. Alright, the next thing I'm going to add is, but maybe we want them to live a little bit longer, so I'll explain the lifespan here. So usually if you want your particles to kind of stay on screen longer, you're going to want to set this number higher. A negative lifespan will actually indicate to make them live forever. And it's important to remember that when you change these settings, that it's not updated live. So only new particles are going to be emitted with these updated settings. And so you'll see that these guys are not dying out. They're going to live on forever. And eventually they're going to overload your computer. So I'm going to make them only live for, that's too much. I'll make them live for, I like my 150 number. And run this again. So now I'm going to show you a simple particle force. So here I'm going to say apply custom force. This allows you to apply whatever force you want. And so the things that it takes in are, one, it needs a particle Quelea. So again, we're going to plug in our particle Quelea. And the next thing is it needs a force vector. So let's say I want this to really act like a fountain. So I'm going to choose the unit z, and I'm actually going to set this to be negative. Now, you see what happens if I just plug this in now. They all immediately just start falling downwards by too much. And that's because this is saying go -1 unit down. So if you're working in inches, it's going to go 1 inch down every time step, which is probably too much for now, especially considering their initial velocity. So I'm going to set this again to something a little bit lower, and maybe even a little bit lower than that. This looks about right. So now they're given that initial velocity upwards and also being pulled downwards. And we can visualize this force because it actually outputs the force that it applied to the particle. So here, if I give the particle's position as the anchor, we can see that each particle is being has this kind of downwards force being applied to it every time step. And the other thing you need is that because this position is output as a list, in case you want to have their positions over time, here I'm just going to choose the first item in that list, and that'll make my scene a little bit faster. Alright, we can also visualize their current velocities. If we plug in their velocity, so we can see which direction they're headed. Now that we have that, I think I don't need to show their position anymore, and now we just see their velocities. Alright, so now, I'll continue here. So each force has a weight multiplier, so this is how much that force is going to be, going to affect the particle. So a weight multiplier is of 1, will affect it just as strong as it originally calculated, but as you drag this downwards, it's going to indicate to kind of multiply that resultant force by a smaller number, by this 0.5 number, which is going to have it affect the particle less. And of course, if you weight it by 0, this isn't going to affect the particle at all. So here we can see the force is all zeros. I also output this desired velocity, meaning this force's desired velocity is this, but this is the force that was actually applied to the particle. And actually, you can go all the way down to -1, and you can probably guess what's going to happen. I set this weight to be negative. You see when it's positive, it puts this downward force on them, and when it's negative, it's going to apply an upwards force on them. We can see the difference between that and a 0 force. They kind of go up a little bit faster, right? And stay going upwards. Alright, so that's the weight multiplier. I'm going to set this back to 1. This allows you to kind of weight different forces by different amounts so that they affect the particle differently. And lastly, this apply boolean is a very useful little thing, but essentially says, it determines whether or not to apply this force. So a dumb thing to do might be to say, don't apply this force, in which case it's not going to apply that force, and it's the same as if you kind of didn't have this force at all, right? There's really no difference between not applying and not having it. However, the benefit could be that you might say only apply this downwards force when the particles are within a certain bounds. So let's say only apply this downwards force when they are contained within this region of space. right? So now we have this cube. I'm going to say there's some sort of analysis point in B rep, right? So if we have our B rep, and then we have our position, which would be these positions, we get a list of booleans saying whether or not that particle is within this B rep. Eventually, some of them must be within it right there. So what if we were to use this as our boolean? And now that downward force is only being applied here, and we can visualize that here. So we can see that downward force is only being applied within this container. Hopefully you kind of see the potentials for something like that. Alright, so we've covered forces. I'm just going to go back to applying this. This is a pretty expensive operation, so I'm going to disable it, and we don't need to preview this anymore either. Alright, and we don't need this. Alright, so back to, let's talk about more emitter things. So continuous flow. Or actually, let's go with creation rate first. So creation rate pretty much says how often do you want. I think my computer is slowing down because of how long these guys live for, and there's no reason for them to live that long. Alright. So creation rate is going to determine how often it's going to emit a new particle. So when continuous flow is true, creation rate is going to say, emit every frame. However, if I were to set this to 2, it's going to say emit every other frame. In order for this to really be noticeable, you might drag it up to something like 10 and say emit every 10th frame. I'm going to bring back this down to 1, and let's continue. So that's creation rate. The next thing that we might control is whether or not to be continuous flow. So right now continuous flow is set to true, and that's why they're emitted every frame. If I were to set it to false, you see they stop being emitted, right? Because they're not being emitted at every frame. However, even when I reset my scene, you'll see that we don't get any Quelea, and that's because the number of Quelea parameter is pretty important for the continuous flow parameter. So if I set this to false, I need to set how many Quelea to emit at a time. Let's start with 1, I guess. If I say emit 1 Quelea, it's going to emit 1 Quelea, right? If I were to say 10, or let's say 100, boom, it's going to emit 100. That makes sense. But what about when this is set to true? How does that affect it? I've reset it over here. So if I were to drag this down again to 0, we'll see that it doesn't affect it. It doesn't affect it when it's at 0. But when I set it to, say, 1, it's only going to allow 1 Quelea to remain in the scene. So let's set this lifespan to be pretty low so we can see it. But yeah, so there you go. So even after the particle dies, it's going to emit that another Quelea. So if I set this to 3 or 5, it's going to emit 5 and wait for them to die before it emits any more. And the point is pretty obvious. I'm not going to explain that. Alright. So now we have those settings, and I'm just going to disconnect this so that they're emitted every frame consistently. So let's look at the particle constructors. The up direction, usually you're going to want to leave that alone. That's just signifying the orientation of the particle. Usually you're going to work in real 3D space, but let's say you want it to work inverted, or I don't know, you could set a particular up direction. The next parameter you can play around with for particles is you can give them an initial acceleration. So here, if I were to give them an initial acceleration in the x direction, they're going to start flying off that way. So we're going to tone it down a little bit, maybe something like this, so that they are accelerating a little bit in that direction. I'll bring this up a little more obvious. So that's initial acceleration. We've seen lifespan now. Right? That's how long they stay on the screen. Right. And then mass. So this is how much forces are going to affect them. So here, if I set their mass to something much higher, like 10, we should see a noticeable difference in terms of how much that force is able to affect the particles. You can see there it's affecting a lot slower. If I set lifespan higher, you'll see it. But essentially it's a kind of a damping mechanism. Then we have body size. This is really going to come into effect if we have an environment. So let's make an environment. So I'm going to use a box environment. Oh, that's an emitter. And we have an axis-aligned box environment. Axis-aligned just means that you can't have like a rotated box or anything like that. Then we're going to do a box, and I like the center box. Let's just start with this. So give it the environment, and it pretty much just restricts their movement to that environment, in this case this box, but they're not really avoiding it in any way. So let's make them bounce around in there. So here, if I choose my particle forces, particle behaviors, here's bounce contain. So this takes in, again, our particle Quelea and also an environment. So here's our environment. And now they're bouncing around wildly in that environment. I think we need to make this sort of, it's like 1, let's set it to 5. Now they are bouncing around in that environment. So now let's say we wanted to represent our particles as spheres. Let's use their position here, and their radius is going to be governed by their body size. So here we're going to keep the body size at 1, and for radius we actually need to take the body size and divide it by 2 to get the radius. And we can see that the particles do indeed bounce off of the sides of the environment, and as I change their body size, you'll see that it should interact. And in fact, remember that when you change these parameters, they only get updated for new ones. So here we can see that their body size is being used to determine the extents and how they should interact with that environment. So this whole sphere thing has taken a long time. So I'm going to go back to not visualizing them as spheres. So now they're bouncing around our scene. But maybe you want to save their positions over time to draw a line of their trail. So that's what the history length is used for. So here when I plug in my 15, we can see that if we preview this component, we'll see that it is saving every last 15 positions. And so what I like to do is use a polyline. You can use what the hell was that? Polyline, and use these as the vertices. So you can use a interpolation line as well, but sometimes it doesn't work because of the differences between one point to the next could just not be used for interpolation. But in this case, it works, and we're able to get these trails. I think that covers it. We went over a lot. I went over every single parameter of every single component for just a basic scene for particles. So I'll be doing more videos like this for things like agents and Brandenburg vehicles. But there you go. I'll see you in the next one.